In the world today, there are over 20,000 institutions of higher learning, including universities. The amount of teaching and research that occurs in these is phenomenal. But how do academics decide what's true and what's not? How do they judge between different and competing theories? These questions all concern academic culture and how it came to be. The methods used in universities are generally described as academic because they originated in institutions once called academies. We've seen that these academic methods differ from everyday methods, and in this presentation we'll look at the development of academic culture through an examination of its 2,500-year history. Firstly, we'll look at the original academy and how truth was established through reasoning at that time. Then we'll look at the gradual change whereby academic culture came to include experimental verification of ideas. This includes the rise of the universities and the work of Galileo Galilei. Finally, we'll reflect on academic culture in the modern world and on how you can participate in it. Academic culture started in ancient Greece at a place called Platos Academy. The academy was a place of learning where younger scholars would visit older scholars to listen and learn, and where older scholars would discuss science and philosophy and record their learning in scrolls. The first such institution, Plato's Academy, was established in Athens, and the second, called the Lyceum, was established by his student Aristotle, also in Greece. The ancient Greeks believed that science and philosophy were sacred pursuits, but they also put their knowledge to more practical uses. The first academy was built on the ground that was sacred to Athena, the goddess of wisdom, but also the goddess of war. The Greeks saw no problem with this dual role for Athena, and this gives you an idea of what a lot of Greek science was used for the development of superior weapons and tactics which they could use to defeat their enemies. One of the most famous scientists of the classical era was Archimedes, who lived on the island of Sicily, which was at that time controlled by Greeks. Although he was not a warlike person, the rulers of Sicily made Archimedes use his brilliance to develop many powerful weapons, such as a giant magnifying glass to burn enemy ships, and a giant crane to lift those ships out of the water. Despite the individual brilliance of some scientists like Archimedes, academic culture, as practiced by the Greeks, had limitations. Greek scientists would build careful arguments based on logic and reasoning, but they did not have a well-developed notion of evidence or experiment to support their arguments. And without evidence and experiment, they had difficulty proving that their theories were correct. So debates remained unresolved, and many competing theories existed at the same time. For instance, in the classical era, the period between ancient Greece and ancient Rome, two scientists worked on the size of the circumference of the Earth. One of these scientists, Eratosthenes, used a sound method and arrived at a very close result. Unfortunately, he was not the only famous classical scientist, so different theories of the circumference of the size of the Earth existed at the same time. These different calculations were passed down from generation to generation, meaning that no single and correct calculation was handed down. After the Greek and Roman world collapsed around 500 AD, there was a lot of upheaval in the Mediterranean and the European world. Greek learning and mathematics eventually resurfaced in the south after the rise of Islam, and Aristotle and other Greek thinkers came to be greatly respected. On the other hand, in Europe, literacy in mathematics fell into decline for about 500 years, for a period known as the Dark Ages. After the year 1000, however, there was a gradual revival in academic thinking in Europe, especially in reading and writing in Latin and Greek at church schools. By the 1100s, literacy and learning was getting stronger still, and the first universities opened. In Bologna, Italy, in 1088, in Paris, France, in 1150, and at Oxford, England, in 1187. Meanwhile, in the Islamic world, Baghdad was threatened by conquest from the east by uncivilized peoples, and this would disrupt scientific development in that part of the world. In Europe, though, the number of universities continued to grow, and reading, writing, mathematics, basic medicine, and public speaking gradually replaced religion as the focus of study. A growing number of ancient Greek scientific works were acquired, often via the Islamic world. There was still not a tradition of testing theories using evidence, and few people dared to question the Greek thinkers of 1,000 years ago. However, as several of the ancient authorities were in disagreement, this respect for reputation caused problems. Although few in the pre-modern world appreciated the importance of evidence, and they relied too much on reputation, there were some pre-modern scientists who had made use of experiments. For instance, we mentioned Archimedes, and he conducted some very famous experiments, but few followed his lead for 1,000 years. And there was also the Persian Ibn Sina in the Islamic world, who constructed the first drug trials in 800, and he used scientific principles. But he was also an isolated genius in his time. Only many centuries later did people finally start to appreciate the brilliance. One university student in the 1600s was very impressed by the way Archimedes had used evidence and experiment, and he consciously followed this experimental method. This student was the Italian Galileo Galilei, who became famous for making the use of experimental evidence famous. Galileo's breakthrough was to use experiment and observation to make new discoveries, including making observations with the first telescope. Galileo was not too concerned if his discoveries did not match the discoveries of the ancient authorities like Aristotle, and this newfound confidence changed the nature of academic thinking and academic culture, and helped usher in the modern world. One of Galileo's most famous experiments concerned the speed of falling bodies and the existence of gravity. He dropped 2 cannonballs of different weights from the Leaning Tower of Pisa. One cannonball was empty inside, and the other was solid and weighed far more. However, they hit the ground at exactly the same time, and this proved that objects of the same profile fell at the same rate, regardless of their weight. This opened up a whole new field of inquiry, because it showed that the views of Aristotle, that everyone was following, were incorrect. Although Galileo did point the way to a new scientific understanding of the world, by showing the theories of the old Greek masters to be wrong, it was actually Sir Isaac Newton who completed his work and explained the force of gravity using mathematics. Galileo's real achievement was to make experiments popular within universities and to give academics the confidence to question their ancient predecessors. So to establish something as fact at university, after Galileo, it was not enough just to present a chain of reasonings, as the Greeks had done. Instead, it was necessary to present a chain of reasoning backed by evidence based on experiment, and other academics would eventually agree that this was the best method, and it became known as the scientific method used to present an academic argument. The use of evidence grew from faculty to faculty, from field to field, and from year to year. And evidence is now used extensively throughout different faculties at university, and theories become established as truth when they use reasoning backed by evidence, and when enough of the academic community accepts these theories. The process of presenting and commenting on academic arguments exists in all disciplines, from the physical sciences through business, computing, and into the social sciences and the arts. There are differences in what constitutes acceptable evidence, but the basic process of reasoning based on evidence and academic agreement remains the same. Now it's your turn to partake in academic culture. You may not have the brilliance of Newton or Galileo, but you can still make progress at university if you construct well-reasoned arguments backed up with evidence, and if you show your understanding of the theories of others. If you do this and you work hard, that will lead to graduation and to your graduation ceremony, a great moment of pride in an academic career. Thank you.